and today I wanted us to focus on a Form 4 topic, which is radioactivity, which is going to be our today's topic. And in radioactivity, mostly we are going to deal with reactions that are originating from the nucleus, unlike in Form 2, where we are studying the structure of an atom and the valence electrons. So we shall have to know some terms, which is a nuclear reaction. Nuclear reaction is going to be one of our terms that we have to define in our topic. We are also going to define another term, which is a nuclide. A nuclide, and in the course of the topic, we are going to see that there are stable and unstable nuclides. And for the stable nuclides, we are going to find that they have a ratio of neutron to proton of 1:1. That is the ratio of the most stable, and the stability goes up to 1.6:1, where N is representing the neutrons and the B is representing our protons. B is representing protons, so the ratio will be 1:1 for a nuclide to be stable. We are also going to find another term, which is radioactivity. The topic itself, like you can see, is radioactivity. So we shall have to define the term also, radioactivity. We are also going to define what is radioisotopes. And you remember that in Form 2, you saw isotopes. And my students, do you remember what are isotopes? We said that isotopes are atoms of the same elements with the same atomic number but different mass numbers. Now in our topic of radioactivity, we are going to see now what are now radioisotopes. We shall define the term radioisotopes. There is also another term that we are going to see, and that is radioactive decay. Radioactive decay. And under radioactive decay, we shall also see radioactive decay series. We are going to see radioactive decay series. Decay series, it is also another term that we are going to see. From a radioactive decay series, now we shall come to a radioactive substance. A radioactive substance. A radioactive substance. We are going to see, when do we say that a substance is radioactive? So, like we have said those terms, what is a nuclear reaction? What is a nuclear reaction? And a nuclear reaction is a reaction originating from the nucleus. Any reaction that originates from the nucleus is referred to as a nuclear reaction. A nuclear reaction. And most of radioactivity equations will be revolving around the nucleus. So we shall see that radioactivity is a nuclear equation or reaction and not a chemical reaction. We shall see where is it that radioactivity is a nuclear reaction and not a chemical reaction. We shall see that in the course of the topic. So a nuclide, what are we saying is a nuclide? A nuclide is a particular nuclide characterized by its proton and neutrons. It is a particular. So, like I'm saying, a nuclide is a particular, not nuclide, but it is a particular nucleus of an atom. Particular nucleus of an atom. So, a nuclide is a particular nucleus of an atom that is characterized by its proton and neutrons. And I have said that we are going to see that we have stable nuclides and unstable nuclides. So another term is radioactivity. The topic itself is radioactivity. What is radioactivity? And radioactivity, it is the process where an unstable nuclide, a nuclide that is not stable, breaks up to yield another nuclide of different composition with emission of particles and energy. It is the process where an unstable nuclide breaks up to yield another nuclide of different composition composition with emission of particles and energy. And the examples of particles we could be having alpha particles, which is characterized by that. We could be having alpha particles or beta particles, or we could also be having the gamma rays. So it will emit particles and energy. That is the term fission. It is the process where an unstable nuclei is breaking up. It will break up to yield another nuclei of different composition, but it will emit particles and energy. So when we say that a substance is radioactive, a radioactive substance, a radioactive substance is substance which undergoes radioactivity. Any element that is going radioactivity, we shall say that it is a radioactive substance. And we can have an example of uranium. We can have an example of uranium, e.g., we can have uranium. It undergoes radioactivity, and so it is a radioactive substance. We also see that we shall define another term, which is radioisotopes. And I know that from your knowledge in Form 2, you know what is an isotope. And we have said that an isotope is an atom of the same element with the same atomic number but different mass number. Examples of isotopes we can have E.g. we can have oxygen, which is 16, and we can also have oxygen again, which is 17. So these are isotopes of oxygen, the same atomic number but different mass numbers. Those are the isotopes. Now, radioisotopes. These are isotopes which are radioactive. And remember that a radioactive substance, it is a substance that is undergoing radioactivity. And now, our last term that you are going to see is radioactive decay. And they have said that we are also going to see radioactive decay series. And we shall have an example of thorium, which is unstable, and it is going to decay in a sequential and continuous process until we are going to get a stable nuclei, which will be lead metal. So this is the spontaneous disintegration of a radioactive nuclide. The spontaneous disintegration of a radioactive nuclide is what we refer to as radioactive decay. The spontaneous disintegration of a radioactive nuclide. And now, having tackled the definition of terms that we had in our introduction, which was nuclear reaction, nuclide, radioactivity, radioisotopes, radioactive decay, radioactive substance, I want us to see the types of radioactivity. How many types do we have? We have two types of radioactivity. And one, we have natural radioactivity. And the other one, we have artificial radioactivity. We have two types of radioactivity: the natural radioactivity and the artificial radioactivity. And where does a natural radioactivity occur? Natural radioactivity, it occurs when a radioactive nuclei split spontaneously. Yielding a new nuclide with emission of radiation and energy. It is occurring when a radioactive nuclei splits spontaneously, yielding a new nuclide with emission of radiation and energy. That is now the natural radioactivity. It is just occurring spontaneously by itself. It is natural in nature. But now we have artificial radioactivity. And when does artificial radioactivity? It occurs when a large stable nuclide is bombarded. It has to be bombarded. A stable large nuclide is bombarded with fast-moving energy particles. It is bombarded. What is bombarding? It is fast-moving energy particles that bombard the large stable nuclide, and that is what we refer to as artificial radioactivity. After now we have seen the types of radioactivity.